Welcome to Mr. Chalk's Revision Tips. In this video, we will look at conservation of mass, some examples, and some reactions involving gases. So the law of conservation of mass is the definition that states mass cannot be created or destroyed, but is changed from one form to another. So in a chemical change, the total mass of the reactants must be equal to the total mass of the products. So in chemical reactions, the mass of the chemical components before and after must be the same. The mass conservation was first demonstrated in chemical reactions carried out independently by Lavoisier and Lomonosov in the 18th century. I apologise that I've pronounced Mikhail's name incredibly wrong. And in every chemical reaction, the same mass matter must end up at the end as you have at the start. So, if we look at this example, if we're working out the mass of the product produced when reactant A reacts with reactant B, it must be 50 plus 50, which would give you 100 grams. If you were working out what the mass of reactant B would be to make the mass shown in the product, you're going to see the product minus reactant A, which means that the other reactant must be 9 grams. The diagram above shows the mass before and after reactions, how much mass is lost. So in gaseous reactions, some of the gas might escape, so is lost, and we can work that out by seeing what the original mass is minus the start mass, which would be 0.3 grams. So when magnesium is heated, it reacts with oxygen. So what mass of oxygen reacts with the magnesium above to give the mass of the magnesium oxide? It's got to be the mass of the magnesium oxide minus the mass of the reaction, which is 2.4 grams. Reactant A reacts with reactant B to produce products A and B. What is mass of product B? You're going to do the total mass of the reactants minus the mass of the product that we know, which would give us 15 grams. So we know that atoms are the smallest particles of an element that can take part in a chemical reaction. So during any chemical reaction, no particles are created or destroyed. So the atoms are simply rearranged from the reactants to the product. So the total mass, or the total atomic mass of the product must be the same as the total atomic mass of the reactants. So for instance, if we're reacting 2 sodiums with a chlorine, that will be the same as the mass as 2 sodium chlorides. So we can see this, that the mass of the products will be 78, which is the same as the mass of the reactants. It's important to remember that the mass changes only occur because a gas is being released into the atmosphere when we go and heat something up quite often. Right? Things aren't being made or destroyed. Or a gas is binding to the magnesium, for instance, from the atmosphere. So, if we think about what the change in mass is when the magnesium is heated up, it went from whatever it was to high mass because it's reacting with the oxygen in the air to make magnesium oxide. What is the magnesium reacting with? It's oxygen from the air. And finally, why is it difficult to get the same value before and after the reaction? It's because we don't know exactly how much oxygen there is that it's reacting with. If we are looking at a reaction where a gas is being lost, so we're starting at 800 grams, if we go and look at how much mass is being lost, it would be 10 grams because that will be given off as carbon dioxide.
Thanks for watching.